Good day, engineers. This is Fieldwork number 3, Area Determination of Polygonal Field using Tape. Preview. A common problem for a surveyor is the calculation of the surface area of a specific field. Before anyone starts to measure a field, he should first look at the field to see what shape it has. The fields are often irregular, which makes direct calculation of their areas difficult. In such case, fields are divided into a number of regular areas, such as triangles, rectangles, etc., of which the surfaces can be calculated with simple formulas. All areas are calculated separately, and the sum of these areas gives the total area of the field. The objective of this fieldwork is to develop and acquire the skills of determining the area of a polygon in the field using tape by dividing the area into triangles. The materials needed for this fieldwork to be accomplished are 2 pieces of range poles, 1 piece of measuring tape, plumb bobs, marking pins or chalks. Now, let's proceed to Part A, Area Determination by Base and Altitude. Step number 1. Assign 5 points in the field which will serve as the corners of the polygon. Step number 2. Mark these points with marking pins or chalk. Name these points as A, B, C, D, and E. Step number 3. Divide the polygon into 3 triangles by taking into consideration that the divisions should be easily measured. Name the triangles as A1, A2, and A3. For the 4th step, measure the base of the first triangle chosen in the polygon using tape. And for the 5th step, measure the length of the altitude of the first triangle. Step number 6. Repeat these steps for the chosen 2nd and the 3rd triangles of the polygon. Now, let's proceed to the calculations of data. To get the area of the triangle, divide the product of the base and altitude to 2. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3. And for the last step, record the length of the base, altitude, and calculated area on Table 3.1, namely, area determination by base and altitude.
Part B, we have area determination by 2 sides and an included angle. First, same field described in Part A will be used for this method, but change designations on the corners. Second, assign 5 points in the field which will serve as the corners of the polygon. Instead of A, B, C, D, and E, mark these points as F, G, H, I, and J. Divide the polygon into 3 triangles. Name these triangles as F1, F2, and F3. Measure any two sides of the first triangle chosen and label these measurements as sides A and B. Repeat these steps for the chosen second and third triangles of the polygon. To get the area of the triangle, divide the product of side A, side B, and sine of the included angle to 1/2. To determine the whole area of the polygon, take the summation of areas of A1, A2, and A3. Lastly, determine the included angle between sides A and B and record this on table 3.2, which is area determination by two sides and an included angle. Lastly, we have the part C, which is area determination by Herons formula. First, same field described in part A and B will be used for this method, but change the designations on the corners. Second, assign 5 points in the field which will serve as the corners of the polygon. Next, mark these points as K, L, M, N, and O. Divide the polygon into 3 triangles. Name these triangles as K1, K2, and K3. Measure all the sides of the first triangle chosen and label these measurements as sides A, B, and C. Repeat these steps for the chosen second and third triangles of the polygon. Next one, determine the semi-perimeter of the first triangle by multiplying the perimeter of the triangle by 1/2. To determine the area of the triangle, substitute the values of the semi-perimeter side A, side B, and side C to Herons formula. And the next one, to determine the whole area of the polygon, take the summation of areas of A1, A2, and A3. For the last step, record this on table 3.3, area determination by Herons formula, which is listed on your screen.